the report of this procedure as by kind of taking the picture of a report that they put on on their table, just took a picture with their cell phone, sent that over to us as a text message, and we were really unsure what that meant because it was very small text, very kind of heavy medical jargon, and we did not understand if it was a good or a bad thing. So as a nerd, I fed this to ChatGPT. I told it that that you should now be a radiologist who's very good at trying to explain things to normal human beings and read through this report and explain to me the key findings and the need to understand language. And sure enough, it actually did this really well. So I got 3 headings and each had a bullet point underneath saying like what was going on. And I could read out because I saw that there was nothing really particularly wrong. It was just like she's an old lady, and old ladies have aches and pains. So it's really amazing, I think, what we can do with AI when it's being used in the right way. But at the same time, if you've ever used a AI tool like ChatGPT, sometimes you're like, how can it be this dumb? Like I'm asking it a fairly simple question, in my opinion, and why is it not able to answer this for me? Now, on the high level, a large language model, an LLM, is a fairly straightforward thing. You give it a prompt, you ask it a question, some sort of magic and unicorns happen in between, and you get an answer out the other end. Now, this is all good, but the problem is that LLMs as a concept are very generic. They are a generic tool, whereas what we're trying to accomplish in our business is very much not generic. It's very specific. And I work at a company called Vaadin. We're an open source company that helps Java developers build web applications, as we discussed here with Freddie and folks before the stream started. And we're specifically focusing on people who are building business applications. These are the types of applications you find at almost any company. They're perhaps not the coolest apps in the world, but they're the actual apps that make the world go around. They're the ones running the business processes and making the money for the companies. And one common thing that I see in a lot of these applications is that there's a lot of manual work going into the kind of work process of the end user. There's a lot of stuff there that I think AI would be really well positioned to simplify and streamline and just make people's lives easier because they could go from like manually doing a lot of work to just kind of reviewing and approving it and then spending a lot of their other time on more meaningful things. So I think there are a lot of really interesting things. So that's kind of was my idea going into this and trying to understand how do we use these tools to build meaningful application experiences for the end users. Now, I'm obviously a Java developer. I'm a Java user group talking, so I didn't want to use Python or JavaScript tools to do this. I wanted to specifically understand what are the tools available to us as Java developers for building these types of applications. Now, one kind of visualization that helps me understand this whole idea of building AI-powered apps is this diagram by Andrei Karpathy that he shared on Twitter a couple of months ago. And he kind of likens an LLM with a CPU in a kind of computer architecture diagram. So as a CPU, an LLM is a very generic thing. It knows how to do kind of computations and stuff, but it doesn't really do much on its own. You need a couple of things to add to that mixture. At a very minimum, you need some working memory, RAM. In LLM terms, this is our context window that we're working with. Very likely, very soon, you'll also notice that, hey, it would be really cool if I could store some of these results or data in a format that would be easy to pull into the mix when we're working with stuff. So this is where vector stores or vector databases come in. It's also really useful if we can give the LLM a limited set of tools that it can work with to perform some tasks for us, or maybe go to the internet and search for information. And also sometimes it's really useful for us to call other LLMs from our LLM because they are trained on different things and they're good at different things. So for instance, one LLM might be really good at creating pictures, while the other one is good at answering text questions or creating code. So it's really kind of easy or good to kind of think of this as a diagram of different tools that we're putting together. And like I said, we are going to look at all of this through the eyes of an engineer. We're going to look at the API. So we're not going to dig into the actual math happening under the hood. We're happy just eating the sausage. We don't need to know how the sausage was made. as long as it tastes good. So specifically today, we're going to talk about three libraries that are out there in the kind of Java ecosystem. We're going to talk about LangChain4j, which is, or kind of started out as a port of the Python LangChain library. Today, I would say that it's not a direct port as much as it's kind of inspired by several other libraries in the Python and JavaScript world, and also bringing some own ideas into it. We're also looking at Spring AI, which is the Spring Team's official AI library, dealing with a lot of the same things. And finally, we're going to attempt to take a look at Semantic Kernel, which is kind of not complete yet as of today, but we're going to look at where it is today and where it's trying to get in the near future. Now, all of these things are moving incredibly fast. So I last did this talk just a couple of weeks ago, and this was what it felt like today when I was trying to update the code to kind of take into account all the new features and stuff that they've added in just a couple of weeks. So things are moving very quickly. So what I'd like you to do in this talk today is really try to understand more the general ideas and concepts of how these things are done. And I'll share a repo where you can play around with this on your own computer. So really, it's more important at this point to understand what the tools and kind of concepts are available to you, and then you can go and look those up in the documentation later on. But we're going to take a look at how all of these things happen in code just to get an understanding of what happens. Now, I want to kind of, as a roadmap for our talk, use this concept of a line of agent autonomy. And this kind of describes how much control we're giving over to an AI as we're building an application. So at the lowest level, we're talking about a chatbot. So this is sort of like classic ChatGPT, where you're just talking with the chatbot. It is able to provide you pretty good answers, but in a very generic way. It doesn't have access to any specific information about your specific thing that you're trying to do. That's where retrieval augmented generation, or RAG, which you might have heard of, comes in. This is where we give the LLM access to some information, whether that's information in our vector store, kind of documents or things that we've made available to it, or maybe it's giving it access to search the internet through different tools, but we're giving it access to more information than that just what's in the LLM's own training data. Now, if we go one step further in the autonomy, we're going to kind of have a co-pilot. We're still in the driver's seat, but we have somebody sitting next to us who is able to do a lot of work for us. So in this case, we're already giving the AI access to a bunch of tools that we're allowing it to use to perform tasks for us. So we don't have to do all those tasks ourselves, but we can just ask it to go and, hey, perform this task for me and use all of these tools that are available to you. And at the other end of the spectrum is essentially fully autonomous AIs, where we just give it a task, it figures out how to do it, and just does everything for us without us kind of supervising it. So we're not going to get all the way there today, but we're going to take a look at the first three in more detail. So let's start with the kind of simplest level of interacting with an AI, a chatbot. And in our diagram, this essentially means that we're using the CPU, which is the large language model, and we're using a context window as the working memory for this LLM. There are a couple of things that we want from a library at this point. So first being that we want to have a swappable support for different language models. Now, there are a lot of new language models coming out constantly. I feel like there's at least one a week, if not more. And it's also kind of a place where you're building the application. You don't want to be rebuilding the application every couple weeks just because a new cool thing came out. So it would be really kind of handy to be able to swap these out one for another, or kind of have different LLMs used for different tasks. So having a good abstraction for dealing with different LLMs is a must-have for any of these libraries. The other thing, in my opinion, that's really important is having a way of managing this context window, which is the working memory of our LLM. So the context window you can kind of think of, like I said, as the working memory. And when we have anywhere from 4 to these days, like up to 200,000 tokens, maybe. Token is sort of a sub word that the LLM uses when it's splitting up content for its internal representation. So it means that, say, a 4,000 context or 4,000 token window would roughly represent 3,000 words in English or Spanish. So that gives you an idea of the size of it. What we need to understand, though, is that we need to fit quite a bit into that context window. So first of all, we need to fit in a system prompt. So in my example with my dog, this was me telling the LLM that it should work or it should behave as a radiologist who is very good at communicating with people. So we're kind of giving it the context of how it should behave. We also need to include the entire history of our chat with this LLM because the actual LLM itself does not retain a memory. So we need to pass that with every request so it knows what we're talking about. We, of course, need to have the prompt or whatever we're asking at any given moment. And most often, then we also need to include some sort of relevant information, kind of something to include in the prompt that's going to help the LLM to respond. And finally, we need to have enough empty space within that working memory for it to actually generate the response there. So say if we have a 4,000 token window, we might want to have, say, 1,000 tokens empty there just so it can produce a response in there for us. Now, with these larger and larger context sizes, it's kind of tempting to just like, well, let me just like put every single thing into this context window and just be done with it. I don't need to deal with vector databases or anything. I'll just put everything in there. The downside of that is that we're typically getting charged by the amount of tokens we're using as we're interacting with these. So the more you put in there, the more it's going to cost you. So it's really kind of in uh, everyone's best interest to just put in what you actually need into the context and not a whole lot more. So another thing that we really want to have typically is a way of doing templates for prompts. So similar that we have templates for creating like HTML for, say, front-end applications or views, it's really handy to have a templating language for the prompts that we're sending. It's not as important when you're just doing one-off kind of questions and answers, but when you're starting to do something more complex where you're kind of one stage of the AI calls another stage of the AI, and you want it to have specific prompts for each stage and pass kind of the output of one stage to the input of the next stage in a formatted way. These become really, really handy. And finally, it'd be really helpful for us to have a way of defining how we want the output of a given call. So as Java developers, my favorite kind of way of getting the output is as a Java object, because that's something that's very easy for me to use in my code. But there are other kind of requirements somebody might have. So you might want to have JSON as the output or XML or something else. All right, so let's take a look at how this looks in different libraries. So if we start with LangChain4j, and what we're trying to do here, let me see if I can get my little laser pointer going. Let's go back here. All right, so what I'm trying to do is I'm trying to call an LLM and get back a record that contains a translation. So the translation record has a string for the original text, a string for the target language, and a string for the translated text. The way LangChain4j works is that we define an interface for how we want to interact with the LLM. So in this case, I'm saying that I want to have an assistant that has one function. It's going to have a function called translate. It'll take in a text and a language, and it's going to return a translation. So it's this record right here. We are able to define a prompt template here. So we can use these double curly brackets for actually injecting these values directly into the template without having to do that manually ourselves. Then in order to get an instance of that service, what we do is we use this AI service builder. We define that we want to have a chat language model. In this case, I'm using an OpenAI chat model, but this is where the pluggability comes in. So this could be any other language model that's out there. So it could be Mistral, it could be Ollama if you're running locally, it could be Gemini, it could be really any model that you're working with. And this way you don't have to change your entire rest of the code just to kind of account for a new model coming out. We're also defining a chat memory. So again, this limits our number of historical messages to 10. That keeps the kind of message window to a certain kind of suitable size. We're not using too many tokens for kind of stuff we don't need. And then to finally get the actual translation, what we can do is we call the translate method on the assistant. We pass in the text we want to translate and the language we want to translate it to. And what we're going to get back is a record that contains all the information. So fairly straightforward. Really, the heavy lifting is in this builder here, and we're going to see how LangChain actually just allows us to add more steps to the builder and just add more functionality to the application. Now, if we take a look at how we can do the same thing in Spring AI, again, we're trying to populate this translation. The thing that Spring AI allows us to do, or gives us in a sense, is it takes care of all the configuration. So we don't have to like specifically say that we want to have a OpenAI chat language model. It's enough for us to just inject a chat client. And in my case, I have the dependency for Spring AI, Open AI, in my POM file, which means that Spring Boot is able to auto configure all of this for me and just inject this chat client for me to use. So there's a little bit less kind of setup in terms of that needed with Spring AI if you're in Spring. But we're going to notice that Spring AI is on a slightly lower level of abstraction. So we need to do a little bit more of these steps ourselves. So here we need to define our own parser, saying that, hey, we want a parser that provides a translation. And we want to have a template that looks like this. So we're using single curly brackets, but essentially the same to define the template. But the thing that we need to add here manually now is this format. And we instantiate the template by passing in a map of these values. So we're, again, passing in the text, the language, and the format we actually get from calling get format on the parser. So this essentially will output a JSON schema that it can use to instruct the LLM how it wants the result getting returned. So when we call this chat client that Spring injected us, we get a result and we then get the output from there and we get the content. So this is obviously a lot longer kind of than we needed to do in LangChain. And this kind of models quite a lot how the APIs under the hood look like. Once we have the JSON that's formatted according to this parser schema, we can then use the parser to say like, "K, return this translation class based on that." And again, we get the same functionality here, just that we had to do a couple more steps explicitly instead of having kind of LangChain4j do those for us. Now, Semantic Kernel got a very big update just a couple of days ago, so I do not have kind of the code right here, but I'm going to show you in their examples repo how this works, so we get an idea of how it works. So Semantic Kernel takes a very different look at how this works. So they're trying to model a Unix kernel essentially with an AI. So it's very similar idea to this CPU in the middle and these all things that connect to it, but they're instead kind of thinking at as a Unix kernel where you're able to kind of add plugins and programs that the kernel is able to then run as needed when it's doing stuff. But the same general steps apply still here. So we are starting with creating a new OpenAI client. Then we say that we want that client to use a chat completion service. So in a OpenAI provides both just normal text completions and chat completions. So it's very explicit here saying that we want to have a chat completion builder. And then we create this kernel saying that we want to use this specific AI service with it. Now, how this works then is that you can have these templates. So let's see if we can find this system prompt here. It's loaded from a file here, but we can see that the format is pretty much similar. So it has double curly brackets and it has kind of this $sign for variables. These that don't have a dollar sign are essentially calling different plugins, and we're not going to get to that right now, but we have the idea that we have those variables that we want to plug in. So the way we do that is we define kernel function arguments, then we pass in these variables that we want. Then we use a prompt template factory to build it with these arguments, and that will give us the system message. So if we compare that to just having that annotation on the LangChain4j, you can see that there's quite a lot more stuff that you need to do here. It's being a lot more explicit in how things work. So LangChain4j is a lot more convenience, and this is a lot more explicit. Anyway, once you have all of that done, you can create a chat history. You can add your message to it, and then you can get the completion by using this get chat message content async with the history and the kernel and a null value for unknown reasons. And that will then give us the answer. All right. So similar concepts on kind of different levels of abstraction. Semantic kernel, definitely the odd one out here in terms of having this concept of a kernel that we need to register a lot of functionality to. Good. All right, so let's take a look at the next step in line. So if we, again, go along this line of agent autonomy, and now we've initially just taking a look at how do we chat with a AI LLM. This is now taking a look at how do we tell it something specific about our context, our specific business context, so that it can give us more relevant answers. So in our diagram, what's happening is we're adding this vector store to our diagram. So we have a permanent place of storing things. To understand what's happening in this step, I think it's good to take a quick step back and just understand what LLMs know in general. So there are two things that they know. One is the data that they've been trained on. So if you're using the big models like OpenAI, it's like ChatGPT-4, for instance, they're essentially trained on more or less the entire internet up to some specific point in time. The other thing that they know is whatever content you give them as a part of that context window, so in their working memory, so to speak. There are a couple of different ways we could go about teaching an LLM things. So the first thing is literally train our own model. Now, this is not a great option if you're not a billionaire or if you want to spend a lot of time. It might be okay if you're doing a very specific model, but like these huge general purpose models are not kind of very, very feasible to train yourself. What is feasible though is fine-tuning a model. So you're taking an existing model and you continue training it with a little bit of examples of your own that are specific to your business context. This isn't terribly expensive or time-consuming. Not all models support this, but it is an option. But by far the simplest and kind of most straightforward way of doing this, and in a lot of business cases, is just putting the relevant things that we know it needs for answering a question into that working memory, to that context window, so that it can use those to reference when it's answering the question. So what this might look like when we're working with a document. So say we want to have this kind of terms of service document available. Now, of course, this is a very small document and we could just put the entire thing in there ourselves, but let's kind of use this as an example just to kind of understand the concepts here. So we have our terms of service that we want to make available to the AI. The first thing we want to do with any document is split it into relevant chunks. So we want to kind of split it into sections that are sort of about one thing per section. The Once we have that kind of split done, what we want to do is we want to generate a embedding based on those. An embedding is a vector representation of the meaning of that text. Now that's a little weird, like if you think about it. So we're taking a text in any language, in this case English, but it could be Spanish just as well. And we ask an LLM essentially to give us a numeric representation of that. So what does this mean in math terms? Now, it took me a while to understand this. And one way of really explaining this that worked for me is comparing it to a color picker. So if you've ever used a color picker, you know that for any essentially any color on the spectrum, you're able to get a RGB value, a red, green, blue value. So again, that's a numerical representation of three values that gives you a unique identifier for essentially any color. Now, intuitively, we know that two very similar colors will have very similar vector values, similar RGB values, whereas two colors that are very far apart will have very different values. So we can use this to our advantage. And that's really why it's so important to kind of split this document into meaningful sections, because if we were to say like, what's the vector embedding of this entire document is essentially asking what's the color of this entire picture. It's not entirely meaningless. You could probably get some sort of median value of the entire picture in front of you, but it's not as helpful as saying like, what is the color of this microphone right here? And that's going to be a lot more helpful when we're trying to look up things. Okay, so we've now kind of split our document into sections and used a embedding model to calculate these vectors. The embedding models is something that we can either run locally on our JVM for simpler things, or more often you probably use like an OpenAI embedding model to generate these. So it's a simple API. You pass in your text, you get back a vector, and that's pretty much it. So you don't need to really understand how the actual translation between text and vectors work there. Once we have the text and the vectors, we put them into a specific vector database. So vector database or vector store is a database that's optimized for working with these vectors. The vectors can be very large, usually like up to towards like several thousand dimensions. So they're not your run-of-the-mill RGB three value vectors. They're very large. But once we have them there, it's going to allow us to fetch meaningful information quite easily. So when a user comes along and asks us a question, say, hey, what's the cancellation policy? What we do is we take that text, we run it through the same embedding model so we get a representation of that question's meaning. Then we go into the vector database and say, like, hey, what are the vectors that are most closely kind of related to this vector that we just gave you? And what should plop out then is whatever section of our document that is most closely related to our question. So in this case, since we're asking something about cancellations, it was able to figure out that the cancellation policy was the most relevant part of this document for our interests. So that allows us to not put the entire document into our context window, but just the part that we need. Now, of course, this is a very small example, and like I said, we could have just put the entire document there. But for instance, I did the same kind of same thing with the entire VON documentation, and that's several hundred pages of documents, and I split them along like section titles, so I knew I had kind of roughly relevant chunks of text then. And that way, when you ask a question, it might actually find one section in one doc and another section in an entirely different doc and a third section in someplace else, and it just happens to know that those three things are the most relevant things to kind of include in answering this question. So it's a really powerful way of gathering the right information to answer a question. All right, so let's take a look at how this actually looks in code. So again, we're starting with LangChain4j, and what we want to do first is just set up some basic things. So we have a splitter. So that's what's going to take care of splitting the documents into smaller sections. Here I'm saying let's use 400 token chunks as a default, and then it's going to recursively try to split the text into smaller pieces if needed. Here I'm using in-memory both embedding models and stores. So this is our example application. In order to keep it very easy for you to run on your own computer and not require a whole lot of calls, we're using in-memory models. Again, the beauty here is that these are behind interfaces, so you can change these to be any kind of model. So the embedding model could also be an OpenAI embedding model. The memory store here could be Pinecone or Postgres or anything else that you might be using without having to change any of the rest of the code. So it's really powerful in that sense. So what we then do is we define an ingester, which is kind of what is used for taking in documents and storing them in that vector store. So it has access to that splitter and the embedding model and embedding store. So with those, it's able to do all the steps that we just walked through with the document. So the only thing we need to do then is get a hold of our document. So right now I'm just reading in the path of my file, and I'm telling LangChain to load the document as a text document and then ingest it. Now we could also pass in an entire directory here, and we could define different parsers for different file types. So if you have a big folder that has PDFs and markdown files and HTML and stuff, they could figure out how to parse all of those. But here we're keeping things just simple. Once we have everything in our vector store, or in our embedding store, I should say, because that's what I'm using here, we can define a retriever. So this is like the opposite of the ingester. It uses the same store to kind of same database to fetch things out of. It uses the same model so that it can take our question and turn it into that vector. And then we can say how many results we want, how relevant we want as the kind of minimal threshold for it. So in our very simple example here, I'm using kind of maximum of 2 results, and they should be at least 0.5 relevant. These are things that you want to play around with in your own application to find kind of a good balance. But for this example, this works pretty well. Then the rest of it is exactly the same as we had before. So we're using the builder to create our assistant. The only thing we're adding here is this one line saying that use this content retriever to augment the search. So whenever we ask a question, it's going to transparently to us go here and search for the most relevant documents to include in that query. So right now, if we ask our assistant, what's the cancellation policy? It's going to run the retriever to fetch relevant documents, include them for the LLM, and we're going to get a pretty meaningful answer stating what the cancellation policy is. All right. So for Spring, again, we're going to work on a slightly lower level of abstraction here. So we are going to define some things ourselves. So we're going to, again, have a vector store. This is where we store things, the database. We're going to have a text reader. Again, we're just reading a resource off of our class path here and using this vector store to accept it. So in this case, we don't have to define all those things that we did in LangChain4j. It's gonna just take this and split it however it sees. I'm sure you can kind of configure how you want the chunking to work, but in its simplest form, it works like this. Again, we define a template for our query. So in this case, we're gonna say answer the given questions using only the information provided. If you don't know the answer, please respond with I don't know. This is really helpful prompt, by the way, when you're doing retrieval augmented generation. You can essentially tell it to only use this information. If it's not included in this information, don't try to start making up stuff just to be helpful, but just say, I don't know. All right, so again, we're going to ask it the exact same question we did before, but now we're actually doing all these steps manually ourselves. So we start by finding the relevant document by first finding the most similar documents from the vector store. So we do a query based on this, saying we want the top 2 documents with the same similarity threshold. We get a list of documents from there, so we stream over them and we pull out only the document. So if you remember, we stored it into our database, both the vector and the corresponding document content. So in this case, we're just skipping the vector and just taking the document content itself, and then we're joining it with new lines so that we have just a list string containing all the relevant text that we want. We then create a system message by using the template we had on the previous slides, and we pass in those documents into that prompt. Then we create a user message with the same query we used. So we used this query twice now. So once for finding the documents, and then we use it for asking the actual question. We create a list of the message history by putting those 2 together, and then we call it, and we call the client with this entire history. And again, we're going to get a very helpful answer that more or less kind of describes the cancellation policy based on those based on those terms that we had. See, I'm gonna admit somebody into the room here. It's asking me if Ignacio is able to join. All right, so again, very much the same thing. We can notice that Spring AI is on a slightly lower level of abstraction, so we're doing things more explicitly than we are in LangChain. Good. Semantic kernel, I put a shrug emoji because I could not find in their updated documentation a mention of this. I do not think it's because they don't support it, but because they haven't gotten their documentation in order. So when I did this a month ago in Stockholm, they still had this in their documentation on how to do it. So I'm guessing that this is a case of them. So what happened there was that they essentially rewrote the entire library before 1.0, and a lot of things changed. Then it's clear that they haven't caught up on the documentation side there. So my takeaway here is that it's probably supported, but I do not have the code to show you at this moment. All right, but now we're kind of at a stop where we're able to ask the LLM very specific questions about our business because it knows all of those documents that we gave it. Now, the next logical question is like, could we give it some tools where it could actually perform things for us and kind of save us from having to do those things? So essentially what we're doing is we're adding one more box to our diagram here where we want the CPU to also be able to run some different programs or tools. So when we're using tools, we want to define a specific set of tools that we allow the LLM to run. We don't want it to give access to like everything in our project, like, hey, just feel free to run anything you want. We don't want it to give access to our entire database saying like, hey, go nuts, just figure out things on your own. But we want to be very kind of specific about what we want it to be able to do and just provide tools that it can call. So in LangChain4j, this is very straightforward. So you have methods, you add a at tool annotation on top of them with a description of what the method does or what the function does, and that's pretty much all that's needed. So as long as the method name is very kind of method name is descriptive, this is going to work. You can add some more annotations here on each parameter if you want to be more specific about how each one of them should be used. But as a kind of starting point, this is all that's needed. The only change we need to our code is, again, we're adding one more step to our builder here, defining that it can find tools in this class. So in this case, again, we're only adding a specific number of tools here. And now that we call our assistant with a query asking what the square root of the sum of the numbers in hello and world is, we can see that it's calling each of these functions and then providing a accurate result. We all know that the LLMs themselves are terrible at math, so it could not have answered this question accurately if we just asked it straight away. But because we gave it access to these tools, it's able to perform these things on its own. All right, so let's take a look at the same in Spring. And this is something that they added just, I believe, 2 weeks ago. So this was not there when I last did this talk. And it's really cool to see that they have added this recently. So similar idea, slightly different API. So instead of just annotating methods, what we're going to do is we're going to define or kind of register beans that are functions. So we are in a configuration class, so we're able to define bean creations here, and each function needs to be of the Java type function with an input value and an output value. I learned that the input value needs to be an object. It can't be a primitive type, so or even like a string. So it can't be just an integer or a string. So that's why I had to create these records that wrap strings and integers. The output is able to be an int or a string. So again, we define a description, what the function does, and we then in our, before calling the AI, we create options object here where we define that we want to use specifically these three functions when we're calling it. So when we call the client, we create a prompt that is our text prompt, and these options that define, hey, you're able to use these three functions when you're answering. And when we call it, it's going to do the exact same thing. So we're going to get a approximate or a accurate result based on that. Good. So let's take a look at semantic kernel. It's quite similar to LangChain4j in that you have a class where you define a function. You can add a annotation uh, where you define the name and the description. And then here you need to be more explicit with the parameters where you define the actual parameter names and descriptions. So very similar to how LangChain4j works. And then if we look at where we're actually using those, let's see here. Okay, yeah, so here it is. So it's defining a plugin factory for this plugin here. And then when it's creating the kernel, again, if you recall, semantic kernel uses a kernel as the entry point to everything. So it's registering this as a plugin to the kernel. So whenever it needs to run a test that requires one of these things, it's going to pull the right tool out of its toolbox. So this is kind of, we see that semantic kernel has a lot more kind of setup going on, but it's very much designed to be kind of using all these tools and functions that you attach to it. So I think it's probably a very kind of big and complex tool for simple tasks, but as your tasks become more complex and you want to have more steps and things happening, then all of this kind of boilerplate and setup starts to make a whole lot more sense. All right, so at this point now, we're at a point where our AI is able to access our kind of specific information about our business in terms of our terms of service. It's also able to use some tools to actually perform computations or access kind of things on in our system. If we were to take things one step further and kind of go fully autonomous, we'd kind of go a little bit further than any of these libraries are going right now. But I think it's a interesting area to look at, and I can recommend reading this blog post by Bill Gates about how AI agents are going to change the way we're using computers in the future. And basic argument being that as AI agents become more capable, they're able to do bigger and bigger parts of our job. So instead of us just giving access to a couple of tools, we could just ask the AI agent to go and perform the entire task for us, and it would first figure out how it should do it, and then it'll figure out what tools it needs to do to do that, and then it'll go through all of these steps on its own and kind of complete it. Now there are already projects like AutoGPT and things that try to do this, and they aren't super successful yet, but it's kind of a matter of time when we're going to be there. I think out of these three libraries, semantic kernel is mostly aligned with this thinking, which is not very surprising given that Bill Gates was of this opinion and semantic kernel is a Microsoft project. But with this plugin based architecture that they have for the kernel, you are able to register also planners. So a planner is essentially a function that is able to make a plan. So if you ask it to like, hey, reserve me get me a restaurant reservation for Thursday, the planner would then be able to figure out like, okay, so for that I need to check his calendar to see what time he's available. Then I need to check my vector store for information about what kinds of foods he likes, and then it can figure out all of these things, and then it can go access the restaurant system and make the reservation and so on. So that would be like a fully autonomous thing. Both semantic kernel and LangChain on the Python side or C# side on Microsoft side do already have some of these functionalities. So I think it's a matter of time when these also flow into the Java side of things, but we're not there quite yet today. So maybe in a couple of months when I do my latest version of this talk, we're going to be there. All right, so we've taken a look at a lot of kind of technical, theoretical stuff, and I want to close out this session by just playing around with an application live and just showing how these different levels actually look and feel in real life, so you get a good idea of that. And I'm going to share the link to this repo so you can check it out and play around with it yourself. So what we have is a reservation system and a customer support agent for a airline, a hypothetical airline. And here on the right-hand side, we have essentially a live view of our database showing all the reservations we have and their statuses and where you're coming from and where you're going. And then on the left-hand side, we have a chatbot where we can actually interact with that and see how things work. So let's see if the demo gods are on our side today. So we can jump into code here. And let me see here. I'm gonna make our code a little bit bigger just in case it needs to be. So let's do 110. All right, so if somebody has trouble seeing that, just let me know. So this demo right here supports both LangChain4j and Spring AI, so you can see how the exact same application is implemented in both and play around in the code. We're going to take a look at the LangChain version here because it's very easy for us to just kind of add more functionality to it. So all of this up here is what we did in the slide, so we don't need to kind of go through that. What we're interested here is just looking at how we're actually creating the assistant. So right now I'm just using the bare minimum. So we're now at the chat bot level. So I'm creating a assistant. An assistant here is an interface that has one method called chat, which takes in an ID just because we want to have kind of different memories for different people. And then the actual message. We define a template for the system message saying like, hey, you're a customer support agent for an airline called Funair. Be friendly, helpful. If somebody wants to change your booking, you need to get the following information. So their booking number, first name, last name. If you're changing something, you need to make sure that it's actually permitted. And if there's a change fare, you have to ask them for consent before going. And then finally, we're injecting the current date because the LLM, again, doesn't know what day it is unless we tell that to them. All right, so that is our baseline that we start with, and we can start interacting with it. I'm going to use dictation here just to save me from typing. So let's see. Hello, my name is Marcus. All right, so good. We got a helpful, kind of friendly reply. It knows it's working at Funair because we did provide that system prompt. Now, at this point, since we're only dealing with a chatbot without any kind of memory, we haven't added a chat memory to this yet. It's very dumb. It doesn't know a whole lot of things. So if I were to ask something like, hey, what's my name? I forgot. It's again trying to be very helpful, but it does not know who I am, even though I just said it right here. But it's telling me like, hey, maybe we can look up your booking number and figure out what your name is. So not super helpful. We need to do better. So let's go ahead and go one step further. We're going to add this memory provider now. In this case, I'm going to use a token window chat memory provider saying that, hey, I want to keep at most 100, or sorry, most 1,000 tokens worth of this chat history in memory. So we were using the message window memory before where we said 10 messages. This is a different one using a window of tokens. There are more advanced ways you could go about doing this. So you could, for instance, start summarizing the chat history to make it more compact if you're doing a very long chat, for instance. All right, so we're going to build that change, and hopefully that's going to refresh here. This UI here is built in Hilla, which is a open source framework that we have, and you can play around with that as well. All right, so now hopefully if we ask it or do the same thing again. Hi, my name is Marcus. All right. Hey, what's my name again? I forgot. All right. Perfect. So now with that memory, it's becoming a lot more useful to us because now it's actually able to give us some context to what we're doing. But again, at this point, we're still only at that chat bot level where we or it does not know anything kind of specific about our thing. So if we go here, ahead and open there's the terms of service. So this is the exact same one that we were looking at in the slides. We can see that we have a cancellation policy. So we can cancel up to 48 hours before a flight, and there are some fees. But let's see what it does without this information. Can you explain the cancellation policy to me, please? It's 101. Not sure why it's asking for that. All right. Let's see what's going on here. So I really shouldn't even need to ask any of those questions for this. Let's go ahead and change the model here. So I was playing around with different models here, and GPT-3.5 is a whole lot quicker, but it's not super smart. So let's go ahead and upgrade our brain to GPT-4 here. Let's see what it's able to do. Hi, can you explain the cancellation policy to me, please? All right, so now it's not getting stuck on those instructions. So here, like we're getting a very long description of what the cancellation policy might be. That has very little or actually nothing to do with the actual cancellation policy that is here. So again, something to keep in mind when we're working with AIs, they can be equally convincing when they're right or when they're wrong. They don't care, and they're going to sound just as convincing either way. So what we're going to do then is we're going to go and add this retriever. So again, if you remember, the retriever is what goes into our vector database and fetches the most relevant documents. So if we build this again, what should happen is that the model now should have access to that document. So if we ask, can you explain the cancellation policy to me? So if we do this, it should hopefully, yeah. So it's like, here's a brief overview based on our terms of service. It says it's 48 hours before. Here are the fees. Here's the process. So now it's actually answering very much more helpfully. Now it's actually based on grounded reality, not something that's completely made up. Now, this is still like, this is very helpful if we're just like looking to get information and might be okay, but it'd be super helpful if we actually were able to perform some simple actions. So let's go ahead and add some tools to the mix here. So I defined some tools here, very similar to what we had on the slides. So I've added a tool annotation here on some of these methods. Now I'm in a Spring application here. So I've injected a flight service here. And what I'm able to do then is I'm able to pass some of these queries to my backend service and fetch data from a database to augment this query. So I'm able to fetch booking details, and I can change bookings and cancel bookings. It takes as input all those things that I told it it needs to have when it's asking or doing any changes. So let's see if that works. So if I go ahead and build this again, should refresh here. And let's see what happens. So I've kind of made the test data such that the first person here is too close to their flight to actually be able to change it, whereas the last person here is able to do it. So let's see if this works. And again, we're doing a live demo, so it might not work, but who knows? Hi, my name is John Doe. My booking number is 101. Can I please cancel my booking? Let's see. All right. So very good. So right now it didn't even try to do it. It says like, hey, it's outside the cancellation window. No can do. Too bad you're going to LAX, whether you'd like it or not. So very good. Let's go ahead and refresh here, get a new chat, and let's see if Robert Taylor is able to make a change. So maybe he doesn't want to go to SFO. He wants to go to JFK. Let's try that. Hi, my name is Robert Taylor. My booking number is 105. Can I change my booking to be to JFK instead? Let's see. Okay, so it's telling us a little bit about there's a change fee. And again, in the system prompt, we told it that if there is a fee, it should ask if that's okay. Yes, please proceed. Let's go ahead and do that. All right. So hopefully, yep, we can see now that changed here to JFK. So that's pretty cool. I mean, this is already much more helpful than most airline representatives I've ever spoken with. All right. Let's see if we can go ahead and cancel it. Actually, we don't want to go to New York. It's not great. So sorry. On second thought, can you cancel my reservation? Let's see if that works. All right. Has been successfully canceled, and boom. Now it shows up as canceled here. So with this example, I wanted to kind of give you a more real life idea of what you can do with these tools. You can find it up on my GitHub. This is all open source using open source tools. And like I said, it's the same exact application is implemented in both Spring AI and LangChain. I am intending to add that semantic kernel version whenever I find enough documentation about it to actually make it happen. I do want to give a big shout out to both the LangChain4j and Spring AI teams because both have been helping out in making this happen. So especially Christian Solov from the Spring AI team has been working with me this week to make the Spring AI version of this application working. So do check this out. It's a standard Maven project, so just run the Maven default goal or run the Spring Boot application class, and it should spin up that server or browser for you, and you can start playing around like we did here. And we'd love to see if you make any changes or build anything cool on top of it yourself. So in summary, where is what's the state of all of these things today? And I want to be very specific that this is today we're talking about. Like this could be entirely different 2 weeks from now. Again, things are moving at a breakneck pace. So a lot of them are kind of providing or intending to provide the similar type of functionality. So we have ways of doing prompt templates, output formatting. Couldn't find it in semantic kernel today, but I'm very surprised if it wasn't actually be there. RAG support, so doing this retrieval augmented generation, uh, message history management tools and functions. Where we really see the kind of differences here is how long they've been around. So LangChain4j started out earliest of these three, which is kind of funny since they have the lowest version number right now, but they are by far the most mature of these three options and easiest to use at this point. They've kind of graduated from that very low level API to having these more high level API helpers, which makes it really easy to use. Spring AI has been catching up really quickly. They've been working really hard, getting new stuff in there. So they're at 0.81, 0.8.1 as of yesterday, fixing specifically that was to fix a couple of bugs in this demo that we're looking at here today. And they also have pretty decent documentation. Semantic kernel, I don't know exactly what's happening there. So last summer they released an initial version 0.26 maybe. Then it was quiet for a very, very long time. And then last week, I believe they came out with 1.0.0 RC2, which was entirely rewritten. So there isn't a whole lot of documentation yet, as far as I could tell. There were the kind of couple of examples that we were looking at and that you can find. But I think it'll take a couple more weeks or months for them to kind of catch up with their documentation to make it really easy for people to get started with that. So I'm not saying that semantic kernel as an idea is very hard to use, but right now with the lack of documentation, it's going to be really going to take a lot of effort on your part to figure out how things work. With that, I want to thank you all for joining me. I think we ran a little bit over, but we started a little bit late too. So uh, if you want to stick around, I am more than happy to take a bunch of questions. If you need to run, that's perfectly okay. Thanks for joining. And I'll hand it over to one of the hosts and see what you want to do. If you have any questions or any other activities you want to do.
Thank you, Marcus. I think that was really awesome. Um, I didn't know that you can do that with Java. So yeah, very nice to see. It's very well supported, right? And as you say, it's moving really fast. So that's exciting for the future.
Yeah. Yeah, it's yeah, the speed at how quick things are moving is a little like it like LangChain is far enough that like I actually didn't have to change anything in my code besides change the version number for it to update. Like Spring AI, there are a lot of new things like function calling that had happened in the past few weeks, and Semantic kernel like entirely changed their entire API. So a lot of things are happening, but it's exciting to see, and I'm super excited as a Java developer, obviously, that there are good tools available so we can build these apps. Because I mean, from my side of things, like so many of the business apps of the world are running Java. So if we can like bring these tools into this context, I think there are a lot of interesting and useful things we can do.
Hey, I do have one question regarding what you were
Yeah.
talking earlier. When you were doing the document splitting,
Yeah.
on the log change,
Mhm.
sorry, you said that you were splitting the documents into chunks that you were controlling. But I wasn't clear about how do you control the chunks. I mean, do they have to make logical sense for a human being, or just split them into whatever the
So,
whatever?
I mean, ideally, if they do make sense for a human, that's like the ideal case. It's hard sometimes to do it. So the recursive splitter here does not really take into account. So the way this is like the naive way of splitting things. So this just says like try to get a roughly like 200 tokens worth into each chunk. The way it starts is it looks like, hey, can I fit an entire paragraph into that chunk? If not, then it splits that paragraph into smaller sections recursively. Now, what I mentioned, what I actually ended up doing in when I was doing this for the VOD documentation was I took advantage of the fact that it was written in ASCII doc. So I had section headers and headlines. So I could say like I could essentially take each section with a headline as one chunk, and I knew that that's going to be quite meaningful as one chunk. So LangChain has all these different splitters for different content types. So for instance, Markdown is quite easy to split up semantically, or anything that has kind of that those semantics built into the format, whereas just plain text or something can be a little bit more difficult. HTML can be easy or hard depending on how semantically valid it is. If it's just a bunch of divs and CSS, probably not so much, but if it's actually like semantically correct HTML, it can be quite easy to split as well.
Copy that. Thank you.
Good. Well, I can probably send the link to uh, the demo again to some of the organizers, and you can forward it to everyone. So you have something to play around with if you want. And of course, it's an open source thing. So if you find bugs or something, report them. Even better if you can fix them, but any help helps.
Yeah, Marcus, there is a question in the chat. So Shaggy asked,
Mhm.
in your experience with long chain and the implementation of multimodals, a general model that sends the questions to a specialized one, do you have tools to facilitate that task?
Yeah, so both LangChain and Spring AI support multimodal uh, uh, models. I haven't got a whole lot of personal hands-on experience on how that like actually works, but the tooling is a little bit further developed in LangChain. Like already the name kind of implies that it's more suited for building these chains, whereas Spring AI is still on kind of the level where you get the basic building blocks where you need to kind of put them together yourself. So in Spring AI, I would probably have, like, if you wanted to do something how, for instance, like how ChatGPT works with DALL-E today, you'd have to do first one question to ask ChatGPT to take your initial input and turn it into a prompt for DALL-E. So it'll take your input and then it'll craft a prompt that it knows is going to work very well for DALL-E, and then you take that and then you send it over to the next model. Whereas LangChain, like as the name implies, you could chain those calls together more easily. The idea certainly with semantic kernel is again the same thing. So you could register, for instance, one function that with a description like takes a vague English sentence and turns it into a DALL-E prompt, and then you would have one function that takes a DALL-E prompt, then turns it into an image type of functionality, and then it should be able to figure out which functions to call to make that happen.
Oh, that makes a lot of sense. What I've seen with I don't know if you have seen that video on Facebook that there's a guy that's trying to remove the chopsticks from an image that he created via ChatGPT, and he asked for the ramen without chopsticks, and then
Oh, yeah.
ChatGPT tried to remove the chopsticks every time he creates more chopsticks into it. It's because I've seen it's just trying to translate the prompt to DALL-E, and that's not like making it what it's supposed to do. But yeah.
Yeah, Christian has a question.
Hi, thank you. I'm Marcos from Mexico. This is not a technical question. This is more about your code. You say that is open source, your code. So my question is currently, I am giving some talks in universities here in Mexico. So I want to know if I can use your code as a demo, because a lot of the universities are using Python, and one of the reasons is because Python is for AI. So I want to know I can use your code as a demo, and another question is where I can config here to change the language to use Spanish, if it is possible to use Spanish in mainly to interact with the AI.
Yeah. I mean, the only thing you need to change is if you ask it in Spanish, it's going to answer in Spanish, so you don't have to actually change anything in the code. So
that's great. So it's automatically.
If you download this and start speaking Spanish to it, it's going to return answer you in Spanish. And that was actually one of the kind of interesting things that I didn't consider initially when I made our documentation assistant for Vaadin, is that even though it ingested all the documentation in English, it's able to answer in any language in the world that it knows. And a lot of this also boils down to when we're talking about the embeddings being numerical representations of the meaning. The meaning isn't kind of tied to a language. So even if the input document is in Spanish or Finnish or English or whatever, the vector would still be pretty much the same because it's capturing the meaning, not the actual text there. So to answer your question, yes, please answer. Please use the demo for teaching. I love if we can teach more children and they can learn in Java. That's even greater. That's good.
Great, thank you.
Yeah, I don't know if someone has more questions.
I do have one more though.
Yeah, and you can always you can find me on Twitter or LinkedIn or GitHub or any place and with the same handle, so you can always reach out there too. Yeah, go ahead. There was a question.
Yeah, me. Sorry. I was actually wondering, you're connecting this with OpenAI API, right? Is there any other alternative this can be connected to?
Yeah. So that's one of the main one of the benefits of these libraries is that they abstract away from the actual implementation. So if we go to LangChain4j, for instance, here, well, I guess we can see here. So you can see all of the ones that they support here. So there's I don't know, 30, 40 maybe in total that they support. That's kind of a mix of both like vector stores and models, but let's see if we can go here. Language models. Okay, so here we can actually see which models they support: OpenAI, Hugging Face, Google Vertex, Gemini and Palm, Mistral, Ollama, Local AI, Bedrock, and a bunch of other models. So, and here you can actually see all those we were talking about, the different types of loaders that they support. So yeah, a lot of kind of pluggable different things you can add there, because all of these use the same interface in Java. So you can start with a local model when you're just playing around and you don't want to pay API fees to anyone, and then you can swap that out for a better model, or whatever. For instance, it might be the other way around, that today, in order to get the performance you need to start with GPT-4, and then as you're rolling out 6 months from now, there's a really good local model that you can deploy within your company, and that way you don't have to send your data out to Microsoft. Maybe that's a great thing as well. So you can kind of swap the actual implementation between or behind the interface quite easily. There are, like, the thing to note though is that because there are differences in model capabilities still, like some models support calling functions, others do not. So that's kind of a limiting factor you want to keep in mind. But for the most part, things work the same.
I have one question. Marcus, I can see relational database in the vendor store. So they have plan to use a relational database, or only for this database that's in this moment?
I'm sorry, I didn't quite understand your question.
Okay, I can see relational database in the event histories. So LangChain have plan to include it?
Relational databases?
Vending story, I can see relational database. I can see Cassandra, Redis, MongoDB, Open Source, Neo4j. Well, I can see relational database. For example, MySQL, MariaDB, SQL.
So the limiting factor here is that does the database have built-in support for vector search? So, for instance, PG Vector is a extension for Postgres. So Postgres itself doesn't, like, out of the box know how to do vector math with 2000 item vectors, but with the PG Vector extension, it can. So a lot of people are using Postgres. I would be very surprised if other database vendors wouldn't be adding this, because then again, like some of these vector databases like Pinecone are very limited in other aspects. So to me, at least, it seems like Postgres is quite a nice alternative, because it's a really good database also for relational data, but it also has a solid support for vector data as well.
Thanks.
Another question. You said when you're doing embedding, it's not like we're doing model training, right? Yeah, but Is there any support for this, at least for LangChain? Is there any support for training models, or this is just for consuming the existing models?
This is just for consuming existing models, at least as far as I know. So if you need to kind of fine tune a model, you would need to use another tool for that, and then you could consume it through here.
Got it. Thank you.
Good. Well, maybe we can wrap up here, and if you have more questions that pop into your head later this week, you can always reach out to me, and happy to answer. And of course, like I don't remember who, but to Christian, I answered that he can then use the demo. Same goes for everyone else here. If you want to show the demo to anyone, you're more than welcome to do it. If you want to fork it and do something else on your own, that's more than okay. That's the beauty of open source.
Mhm. So, ya no hay más preguntas, ¿verdad? No. So, Marcus, thank you very much for the support in our meeting, no, in our monthly meeting. So I think it's very, very interesting, all the thing about AI. So I have a
Yeah.
lot of plan. I have a lot of testing to do tomorrow, because we have a plan to introduce AI in some project. So I have
Yeah.
a lot of things to process now. So
Yeah.
thank you very much for all.
Yeah.
So and we are maybe we make another session, for example, for another team, because very, very interesting, all the thing around the AI, all the thing that you are do. So
Yeah.
in name of the Latam community, no, thank you very much. Y again, gracias a todos por participar y apoyarnos en la sesión de hoy.
Gracias.
Gracias, Marcos. Gracias a todos.
Bye
Bye,
bye a
bye.
todos. Bye bye.
Bye, chicos.